Good morning, everyone. Are there any questions to begin with? Don't forget to press the button, please.
Is there no quiz this week?
Oh, that's right. I needed to re-enable the next set of quizzes, and I didn't do that. So yes, there is no quiz this week. There will be a quiz next week instead. Sorry about that. I hope that didn't disrupt anyone's plans, that there wasn't a quiz. Go ahead.
Are you going to go over threads a little bit more in depth today?
I wasn't planning to, but if you have specific questions, we could do that.
I thought you said on Friday that you were going to go over them more. Maybe
Oh.
I misheard.
Did I? Okay, but we did an example where I did start and join, and I think I finished the bits that I was going to show you. What would you like to know about threads? Oh, I was going to go over synchronization stuff. Yeah, we don't need that for this project, really. It's sufficient to just join all the threads at the end. Right, that's all you need for this one. We'll talk more about the synchronized keyword, which should be review for everyone who's had COSC 1020, but is new for those of you who haven't. I'll talk about synchronized a little bit more in the future, but we don't need that for the current project. Because the current project is embarrassingly parallelizable. And so we don't need any complex interactions between the threads. We just need to divvy up the work and have them all go off and do their thing. And we need to know when they're all done. And that's about it. Yeah.
So when
Press the button.
I did.
Oh, good job. You're way ahead of me.
Yeah. When we do the threading, because when we have to input the number of threads that we want to use, threads they have to be pre-coded before like the threads themselves have to be pre-coded. So are we just like, do we write 3 threads?
What do you mean by they have to be pre-coded?
Because like in the example that you showed on Friday, and then every example that I've seen on the Java sites, they have like, you have to make an object of the thread class.
True.
And then you have to start you have to initialize the thread. Start it so it runs the run method. But like if you created 3 of those, and let's say you wanted to run 4 threads, you'd have to create that thread before you could actually tell it to run 4 threads, right?
That is true.
So you're kind of limited. You can make like 3 threads, right? And then you can have like.
I see what you're saying. So you're thinking of it in terms of I need to copy paste another line of code that creates a thread.
Create more threads like in your code, as you're running the code.
I get what you're asking me. Let me suggest that you can get away with this by using an array of thread objects. You decide how big that is based on input, and for loops that call the start and join methods at the beginning and at the end for however many n threads we need to do. Does that make sense? So then the same code can be expanded to however many threads we need to instantiate an object. We need to call the start method for each one. And then when we're done with the work and waiting for the results, we need to call the join method on each one of those thread objects. Right? And so all those tasks can be parameterized by n, the number of threads, if we use an array of thread objects and loops to do the instantiation, right? Creating the new object and calling start, and then another loop at the end that calls join on each one of them. Does that help?
But you would still need to have to create those threads.
Correct.
Right.
You're still going to have to create those threads. And so if we're asking for 15 threads, you have to have an array of 15 thread objects, and you need to have a loop that creates a new thread for each one of the 15 and calls start on each one of the 15. And then at the end, calls join on each one of the 15 so that we can wait until they're all done to produce the answer. Right? And that same is going to be true for whatever n value of threads we enter. Yeah? Yeah.
Does adding input arguments on join and start screw with the code and makes it not work the way it's supposed to when you extend thread on the class?
You shouldn't need to add anything as parameters in join or start, I don't think. You should be able to pass whatever you need into the constructor of the thread object to begin with.
How would it know which segment of trials to do?
You should pass that information into the constructor when you instantiate the object. Would be my suggestion, right? Because you know how many threads you're going to have and how much you need to divvy up the work before you start creating the first thread. So you should be able to make that decision up front and then hand out the work as you're creating the threads. Does that make sense?
But at least under my understanding of so you put everything that it needs to do under run, the run method, right?
Yeah, the run method is basically where each thread starts its work.
And how is it, like, my question is, how is it going to know which to do in there? Because when I create an object for that thread, how am I going to know which one it needs to do, which set it needs to do? Because I have it in the...
Yeah. So if you pass those parameters into the constructor of your thread, and you have those as local fields, so each thread object remembers what were the values that it was constructed with, then you'll have those available as fields in your run method. And each thread object will see its version of, the start range and the end range it's supposed to do, for example. Does that make sense?
I think so.
You need to think of each thread as being a self-contained entity that knows its business, which part of the work it's supposed to do. Right? And we pass that information in when we create it to begin with, and then when we call run, it should have that information available to it. Right? If you change the nature of run, then I suspect the threading code will not work correctly, because then you're overloading the run method instead of overriding the inherited run method, which is probably not going to do what we want.
There we go. Can we talk a bit more about how the threads are divvying up the work between them?
Yes, but to be clear, that's up to you. There are many correct ways that you can do it, and lots of incorrect ways that you can do it too. But I have not specified how you should divvy up the work. There are many choices.
Okay, that was kind of my question. So I think
yeah, there is not one way that I want you to do that. So you could divvy up the work by saying, I'm going to take the probability range. We're going to do this many chunks, right? And I'm going to take those chunks and I'm going to allocate ranges of p-values to the individual threads. You could have every thread work on every probability threshold, but they each take a certain number of however many simulations we're doing for each p-value, right? So there's multiple dimensions along which you could divvy this up, and there's other combinations that you could come up with as well. Do the one that makes sense to you for building and debugging purposes, right? Think about how you would divvy up this work amongst the 10 people sitting in the row with you if you were going to have humans do this. And if you can come up with a sensible system that everyone would understand and everyone would be clear about what their marching orders were and could use that to get the work done so we could all come together and have the answer at the end, that's probably a good model for how to write your code. And there's not one way of doing it.
While writing this assignment, did you find any specific range of P that we should expect to get so that we know that we're doing something right? I know it's random, but is there like somewhere what we should, like, what kind of ballpark to know that what our calculations are, it's correct?
For each one of the fluid types and for certain grid sizes, yes, there is a correct range of answers that I expect to see. So you should be able to compare, right? It's not academic dishonesty to compare the p-value tipping thresholds that you find when you think you get it working. Right? That's okay to check with some others to see if they got the same answer. I have some answers as well. I don't remember all of them off the top of my head. I want to say for grids of about 100 with fluid type 2, it's in like 0.43, 0.45 range, if I recall correctly. But that's a few days back, so I may not be remembering that correctly at all. But yes, for a given simulation parameter, there is definitely, even though there's a lot of randomness, by performing a lot of these simulations, we expect the Monte Carlo of the simulation to settle on a very narrow range of answer. That's the whole purpose of doing a bunch of simulations, is we get through the randomness because we average that over so many different trials. We get a better understanding of what does this problem really do, right? If you can say, I did 1 million simulations of this forest fire, and when this percentage of the brush squares are dry enough to start on fire immediately, that's the tipping point where we're in real danger, right? That's exactly what we're looking for. Now, in reality, 50% is not a magical number, right? If you were trying to actually assess the danger of forest fire reaching an inhabited town or contaminants reaching groundwater, you'd probably be looking for actually a lower probability than 50% chance, right? We'd probably send up the bat signal a little earlier than that. Better than coin toss. But 50% is what I've given you for this assignment. You understand analytically how you would change it to do a different simulation, right? I mean, if you've got that part, that's one variable you need to change, in essence, which you might even like to have be a statically defined constant up at the top of your class so that it's easy to change. But that's neither here nor there. Other questions? Yeah.
Dr. Bryla, we had one in Brookfield.
Yeah, go ahead.
Just a question with doing the double mathematics for dividing up your probability range. It's just a little bit off. Some of my students are getting just some round off error. Is that any big deal?
No, it shouldn't be, I don't think.
Okay. Other question was just finding the tipping point in terms of working from worst case scenario to best case scenario. When we hit that magic 50%, that's what we're looking for.
Oh, that's a good point. So you might get different answers based upon whether you work bottom up or top down, right?
Right.
Yeah, that's an assumption that I made that I didn't specify in the problem spec. I'm going to assume we're working from bottom up. So lowest probabilities up to the first probability that reaches 0.5.
All right. Thank you very much.
Does that make sense? Does that make sense to everybody else? Right. So we could start from the top, from 1.0, and work down and find the first p-value where we have less than 50% of percolation, right? But given the noise inherent, there's always going to be kind of like a little mid-range there. Probably with a large number of simulations, that's going to give us the correct answer either way, because it's probably going to converge. But I'm assuming you're working from the bottom up, so that might make a small difference in how your answers get reported, especially for smaller grid sizes or smaller number of probabilistic runs. That might make a bigger difference. Cameron, what was your question?
Ask, is the project still due Wednesday?
So far, do we still have an exam on Thursday, most of us? What percentage of the class has an exam on Thursday? Yeah, 2 hands, nice. What's that? Also a 10:20 exam Wednesday. When's our exam? It's 2 weeks from today, right? Yeah, I was going to say it's either 2 weeks from today or 2 weeks from Wednesday. So we've still got time to fit in another one before the exam so we can finish off the cues. Well, when would you like it due? No. No, we can't do next week. We could push it to Friday. If that means people are going to work hard and I'm still going to see a bunch of good questions in my office hours tonight. Right? This is not permission to not think about it until Thursday night. All right, I'll adjust the deadline to Friday at 11:59 p.m. because who has something better to do at their Friday night? Yes, exactly. No, go ahead.
Even if it's due on Friday, would you be able to post the next project on Wednesday?
Yes, I'll plan for posting the next project on Wednesday. But then also, the next project would then also get pushed to Friday of the week following, so that there'll still be a week for that. And that'll bring us right up to the exam week, so that should work out. That should work out just right. Okay, so I'll plan for that, yeah.
Are your office hours tonight the Java review session?
Yes,
or?
so I'm planning on doing Java review session at 9 o'clock. A couple people asked me about doing it earlier at 3, but I have to I teach another class at 4, and so I won't be able to stick around and like ask lingering questions like I will tonight. So, and I expect a bunch of people to come ask questions at 3. So I'm going to keep the Java review session tonight at 9 p.m. down in the lab, down in 310. And then if there's people that have project questions, and I hope there will be, afterwards, I will stay as long as there are project questions. Sense? Other high-level questions about our schedule or the project? Okay, so while we're on the topic of the, oh, I didn't bring my textbook with me. Who has a textbook with them? So our next chapter is chapter number, is it 5? Q's is 4 in the 3rd edition, right? And so chapter 5 is, you're sure that's the 3rd edition, because they renumbered them in the 3rd edition. Help me out here, because I'm confused between the 2 editions too. I mean, I can't remember which chapter is which without the book in front of me, in essence. So we're right now finishing off Q's, which is chapter 4, right? So 5 is the collection ADT, and so we'll finish up much of this week with the collection ADT, and we'll finish off the list ADT by the time we have the exam. All right, so the exam 2 weeks hence. Do you guys have a preference whether it's Monday or Wednesday? So no. My remote sites, the high schools, do you guys have a preference whether it's Monday 2 weeks hence or Wednesday 2 weeks from when, this coming Wednesday?
Monday or Wednesday? No real preference.
Okay. I'm leaning towards Monday just because I want more time to get them graded before midterm grades are due. So it'll probably be Monday, and it looks like we'll be covering up through the list chapter. All right, so not the binary trees chapter. That'll be second half, all right? You are very relieved that binary trees won't be on the midterm exam? All right, that's good. So that is the plan at this point. All right, so to review, current assignment due Friday at midnight. I'll try to have the queuing assignment posted by Wednesday. And that one will be due Friday 1 week hence, and then our exam will be the Monday after that. All right, good deal. Yeah.
I hate to backtrack, but I have one last question on the project because I wanted to check to percolate before I asked it. So if you said start the probability at the lowest point and work up, but if for the percolate class in the last project, p-value of like 0 would just mean everything's open. So isn't it always just going to output p is 0 then? As being percolated if we start at 0 and work up? Because if we start at the lowest range of p and we work our way up the p-values, it's going to start with an open grid and fill it in, and then it's always going to percolate with the open grid.
Right, the probability is the probability of being blocked.
Yeah, so if we start at 1, it's completely blocked, and then it slowly starts opening it up more and more, and it gets a better chance of percolating. Because I just ask it because I started it that way when I was doing it, and I did 0, and I kept getting zeros to p-value, and then I flipped it, and then it started like actually giving numbers of like 0.4 and 0.5.
Yeah, so we're looking for the tipping point probability value p of each individual square being blocked where 50% of the simulations, not the first one where 50% don't. Okay, so I've been stating that backwards when I've been saying it. Very careless. Sorry, I should have been thinking about that because I wrote code for that last week. Sorry. By the time you stop printing them out, it's just numbers that come out, right? So, so am I backwards then in my 0.45? Might be 1 minus 0.45 because of, I need to go rerun it anyway to see what the like. But still, start from 0 and move up, right, to find the first one where it drops below that, in essence. Good point. I've been talking about it backwards and visualizing it backwards. All right, last call for questions before we go back to queues. Yep.
I'm just curious, what's the exam going to look like?
I'm expecting between 4 and 6 short written problems where I will expect you essentially to write Java code to solve a data structures problem. Sense? And no, I don't expect it to be compiler quality. So I don't usually take points off for, you missed one parenthesis here, right? Humans are writing the code by hand. Humans are grading the code by hand. I am looking for the primary ideas of how to approach the problem and the steps that you need to break it down into to be able to spell out in Java how to do it. Also, I will generally not assume that you've memorized all of the libraries. The exam will be at the usual time. Yeah, it's in class. So we'll do 11 to 11:50 the 15th of October, if I'm doing my math correctly, right? There'll be no multiple guess questions, for example. I don't really favor those for 2,000 level courses and above. I actually don't do those when I teach 1,000 level courses. I find those have very little value for me, generally. I'm not a big fan of true-false questions. I like to actually apply what we've been talking about to demonstrate your ability to solve some sort of problem. Those problems must necessarily be much smaller in scale than the week-long programming projects that I give you to work on with 2 people. Got to be smaller versions of that. But at the same time, I will often use those projects as inspiration to ask you about a further extension that maybe with a dozen lines of code you might be able to accomplish. Chapters, because there's lots of good material there that we haven't had time to talk about. I'm assuming that you are reading that before doing the reading quizzes, and that if you have questions about that, you're going to bring them to class about the parts that are not clear. We will probably have time for a little bit of exam review either Wednesday or Friday. Back through the 7 chapters. Is it 6 chapters? I really cannot deal with chapters on me in this new edition. Go back and review what the main ideas are. Perhaps if we have time, actually have you brainstorm what you think good exam questions will be. That's how I studied for my exams when I was an undergraduate. I find that's all right. Back to cues. So where were we? All right, where did we finish off? So we interrupted the flow of things to do our thread demo, which we did finish off, right? That actually worked. And did anybody have any additional questions about that before I go back to our queue, friends? So once again, for the project, I'd recommend, instead of doing 3 explicit named variables like this, do an array of your thread objects, put the starts and the joins in a loop. You should be good to go, right? Remember what we had finished? So this is our array implementation, bounded. We've got an enqueue method that we finished off here. Looks like the dequeue method is finished off. We talked about using the modulus operator to guard the front and rear values so that those were always consistently within the bounds of the array. Quickly implemented the is full and is empty. I missed one. I forgot to do the size one. I added that later on after class, but that is called for by the API in order for this to compile. Were there any other questions about this bounded array-based implementation of the queue data structure? Katie. Just returns the number of elements. That's all it does. All right, so far so good? All right, so the next Q variant that your textbook presents is the unbounded version of this array-based implementation. So how can we make an unbounded version of this array-based Q implementation? Arrays have fixed size. What do you do if you want to make a Q implementation that doesn't run out of space as soon as it fills up the array?
An array list?
An array list. So Java actually has this collection class called ArrayList that works like an array, but whenever it gets too big, it automatically, or whenever it gets filled, it automatically gets bigger, right? Yes, that's true. I could replace my array with an array list, but how does that work? What does that do? Can I do it without relying on the Java libraries to handle this fill up the array case? Yes, certainly I can, to answer my own rhetorical question. How? What does ArrayList do when it fills up? No, that wasn't the question. Did you have a different question, or were you going to answer my question?
You're asking what happens like when it fills up.
Yeah.
Like what we could. So like if you have a normal array, the book suggested that you could actually add to the size of the array, you could. So if you could either double it, and they didn't really recommend that. But you could add by like a certain increment. So every time you get to a certain point, it calls a method, adds to the array, and then you have to reinitialize where the points are, because your array is now a different size. So you have to keep checking for that for when it comes back around. So if you do the loop method, once it reaches a certain point, it'll just add on to the array, and it will take what that previous array was, and it will set those values equal to into the new array. I guess
that is totally the right idea. I want to push you a little bit on the precision of your terminology, because in Java, we cannot make an array bigger. When you allocate an array, it has a particular size. What we're doing is we're making a second larger array, and then as you mentioned with the loop, we're copying over all of the elements from the old array to the new bigger one, and then we replace our elements field in our data structure with that new bigger one. What happens to the old one?
It's still there. It's just that we don't reference it anymore.
Yeah, if it's still there, presumably. If we don't reference it anymore, if there's no references to it, eventually the Java virtual machine will come along and garbage collect it, and that space will be reclaimed to be usable for something else. Right? So we just toss it out, in essence, and proceed with the new larger version. Right? That's a great strategy. That is precisely what ArrayList is doing in the Java libraries, except it's doing it under the hood where we can't see it. Right? It's just got code for recognizing when we've reached our limits and we want to make it bigger. So let's do that. All right, so I'm going to make a copy of this file and call it array unbounded. Should I just call it ArrayQ? We've got the bounded version, and if it's unbounded, well then it's just going to be, we don't have to say the word unbounded, right? It's just going to be an ArrayQ. Yeah, make sense? All right, so I'm going to make a new copy of that. Now, did it actually do that? Yeah, okay, good. So I need to stuff here, wherever I bounded. Structures demo of an array-based unbounded Q implementation. So a lot of this is going to look very similar. This is very much related to the existing bounded example that we did. I'm still going to have a default capacity. I'm still going to have some array of T elements. I'm still going to have to keep track of how many elements I have in each queue. I'm still going to need a front and a rear that are going to circle through, basically. So this is still my my floating front implementation, right? What's the opposite choice from floating front implementation? We're back to the taxonomy we did like 2-3 lectures ago. You can build this as a floating front, where basically front and rear keep moving through the array, and they can both wrap around the tail. That's what the business with the modulus operators is. What's the alternative to that? The alternative to a floating front. You guys just super sleepy today, or just don't feel like talking? Which one? Come on. It's like pulling teeth. Good guess, but no. It is not floating rear. Yes, fixed front. Fixed front. So intuitively, in a fixed front implementation, the front of the queue would always be index 0. So whenever I wanted to get an item, it would always be at index 0 of the array. What would that change about how I NQ and DQ things in my array-based implementation?
Every time you DQ the front of the array, you'd have to somehow either move everything up a space, or it would most likely be create a new array and then take all that old data and then re-add it to the new array, but one position further.
Yeah, so you've got two choices. Either slide everything up one element, or make a new array, copy everything in to one element further up. What is the big O number for each one of those operations? Either way, about how many copies do we have to do if we're going to slide every element in the queue up one place? It's however many values I've got in the array. If we're using this array over a long time with lots of things coming and going, on average, we would expect about how much of the array to be full? About half, probably, right? So what's the big O of that going to be?
Is it linear?
Linear, right? The number of operations you need to perform is going to be roughly proportional to how big the array is, right? Really half of how big the array is, but that half doesn't matter. What matters is the factor n. That as my array, once I've got 1 million elements in this queue, sliding everything down one place is going to take something like 500,000 copies each time. It's big, it's expensive. Same for strategy B of make a brand new array and copy everything over. How many copies do I have to do? One for every element in the array, right? Compare that, and I'm going on a big long tangent here, right? Because I've started making this unbounded queue here, but I'm asking you questions about a different design decision, which was the fixed front, right? We'll come back to this in a second. What's the big O of my NQ for the floating front?
Would it be constant because the front, you don't move any of the values, you just reassign what is considered the front?
Yeah, it's going to be constant time because I've got, an if statement, an assignment statement, an assignment statement, and an addition statement. Depending on how we count, I do like 4 things here, 5 or 6 if you add the complexity of this line. But in no way is the complexity of this line related to how big is the array. Right? The number of milliseconds it takes me to do this does not get bigger as my array gets bigger. It takes as long as it takes to do this many lines of Java code, right? So floating front NQ is constant time, big O of 1, right? DQ, same thing. Just from a high level, just glancing at this code, how do I know that this is a constant time piece of code without even looking carefully at what the code is doing?
You're not looping through anything. It's just an if statement and an else statement.
Yeah, there's no loops. If there aren't any loops, then what I'm doing is not related to how big the array is. Right? I'm just doing constant time operations. If there's no loops and there's no methods being called in here that themselves have loops inside of them, then these are constant time operations. So my floating front implementation of the queue has constant time NQ and constant time DQ. If I had done my fixed front operation, DQing something would mean sliding everything up one place every time I took something off the front of the queue. No matter how we think about that, that's going to be a linear time operation. It's going to be big O of n. Even if we're super clever about it and find a really slick way of doing it, I got to move, on average, half of the array size every time I DQ. So fixed front is easier to understand and doesn't involve fiddling with these circular boundaries for front and rear, but it's much less efficient for large queues, right? DQ becomes a really expensive operation the bigger the queue gets. NQ, as it turns out, is still big O of 1 because I just keep track of the rear index and I put something in there. Right, so I'm not going to implement the fixed front variant of this array-based queue, but I want you to be able to think about it in an exam situation. All right? Any questions about what the fixed front version of that bounded queue would have looked like? All right. So I'm going to continue with my floating front version, but I'm going to make it unbounded instead. So constructor goes pretty much the same, both versions of the constructor. NQ and DQ are going to change because every time I fill up the array, I'm going to make it bigger, in essence. So in a sense, when we come down here to these helpers, size and is empty are going to be the same, but is full, well, if I have an unbounded queue, this queue is never going to be full, right? So the first major change to the actual code in here is I'm going to say is full. It's going to return false for my unbounded version of this array-based queue. Which means that up here in my NQ implementation, well, the first thing I did was check whether or not it was full. And if it was, then I threw an exception. That's never going to happen anymore. Right? Now instead I need to, first of all, find a different way to check if it's full. And second, if it is, I don't want to throw an exception. I want to make the underlying array bigger. Right? So what's that going to look like? Well, if I don't have is full to do this for me automatically, how can I calculate if my array is in fact full? Or rather, how can I calculate if it is time for me to make the underlying array bigger before I add another element to it?
You can check if the number of elements is equal to the array.length.
Yeah, absolutely. I've got this number of elements that I'm using to keep track of how many things I've put in there. And I know how big the array is because I can just ask any array how big it is, right? So what's the case I'm looking for here? Well, it's the very special case where the number of elements, let's try spelling that correctly. The number of elements is equal to the size of that array, which we can get in Java just by asking for elements.length. Make sense? Now, whenever I'm doing a check like this, it behooves us to think very carefully about boundary conditions, off by one errors. Is this exactly the comparison I'm looking for? Do I want greater than or equal to, or less than or equal to, or equal to number of elements minus 1? Is this exactly what I'm looking for? Anyone like to make an argument for why this is correct or incorrect? And it is my sincere hope that by the end of this course, when you are writing code like this, a little voice, possibly my little voice in your head, will say to you, is that exactly the if statement that I need there? Because this is a mental exercise that you should be going through whenever you're writing this kind of if statement. That's checking a boundary case, where if we step over this boundary, we're going to go out of bounds in the array, and then our program's going to crash. Right? This will be a serious error if we don't get this check exactly right. Michael? Go ahead. So where would we have the index out of bounds error if we let the number of elements go right up to the number of spaces in the array? But that's exactly what I'm worried about, right? I'm worried about an index out of bounds if I get this statement wrong. Would it hurt to be on the conservative side and do elements length -1 here just to have that safety buffer? Well, it's a little less efficient, but I wouldn't mock you for erring on the side of safety here if you weren't totally convinced that this was the right line of code. Putting in a little margin of error like that is not a terrible idea. Go on.
I want to do number of elements is greater than or equal to elements.length.
So if somehow number of elements has gotten past the number of elements, that might be a case I want to look for too, right? So if I'm careful, that shouldn't be possible, right? I only increment num elements. There's only two places I change the value of num elements here. I increment it here in NQ, and I decrement it there in DQ down in the bottom. So as long as I'm being very careful, num elements should never get bigger than the actual number of elements in the elements array. Agreed? But there's many other cases where the greater than or equal is, can it hurt us to put greater than or equal here? No, arguably, right? It'll catch the case that I care about where it's equal, and also any weird thing that happens because somehow number of elements gets out of control and it's bigger than it needs to be. So I wouldn't be opposed to that either, but it's not strictly necessary. This does seem to be the if statement that I'm looking for. And as long as I'm careful with the value of num elements, this should be the right condition. If I've allowed front and rear to grow such that the rear has come right up to the value of front, and I've filled every one of the spots in the array, which was the condition I was checking for in the previous is full, right? Then this is the condition I'm looking for, right? Okay, so if that happens, what do? I'm not going to throw an exception anymore. This is the point at which I need to replace the existing elements array with another new, bigger version so that I've got more room, right? So that's a hairy enough piece of action that I'm going to say we should put that in another helper method, right? That should be something that I want to have separate from the actual logic of my Q function. So, try it again. I'm going to call a helper method here called grow. That's going to grow my array and make it bigger. I'm not going to throw an exception. And I'm not going to have an else anymore, because actually this is the entirety of the if statement. And I'm going to operate under the assumption here that this makes array bigger. So when I come back from this call, now I'm actually ready to go ahead and add my next element into the array, right? Because there ought to be space. And as long as my grow can't fail, then we always then proceed on to add something in, right? Okay, so I need to implement this, right? And this is not a method that I want people outside of my queue to be able to access. This is internal. So I'm going to say this is a private method. Doesn't need any special parameters. What am I going to do in here? Well, I need to allocate a new array, first of all. That's going to look kind of like this. Copy that line down. I have to call it something else. I'm going to call it temp elements. I need to declare a type for that. It's going to be the same type as elements up here, T bracket bracket. How big should I make it? The new size should be based on however big the current size of elements was, right? So certainly as a basis, I'm going to start with elements.length. But I want it to be bigger. How much bigger? That's a design question, right? There's not a right answer for this. What would be a terrible answer from an efficiency standpoint? One bigger, right? Make it bigger for one element, which solves my problem for this NQ, but is going to make my NQ operation super expensive because I'm going to make a brand new array, copy everything over every single time, right? We don't want to have to do that every time. But on the other hand, we don't want to make it a whole, million elements bigger if we're dealing with array elements that are only like 100 in size, right? So we want some kind of middle ground here so that we don't have to do this every time. We buy ourselves some room. So you might add in the default capacity, whatever that happens to be. The textbook has a little bit of discussion about just doubling the size of it. That can get expensive as this gets bigger, right? But I'm going to put it in just as a placeholder. We can argue about efficiency later on. But that's OK, right? We could do that. All right, so I'm going to double the number of elements every time I grow it. So I won't have to grow it again until I've NQ'd twice as many things as brought me to the current position. Right? What do I have to do next? Well, let me jump ahead. What do I have to do at the end? I need to replace my array elements with this new temp elements array. Right? That's my last step. When I've come back, that's what leaves in place the bigger array. What do I need to do in the interim here? I need to copy over our stuff, right? What else do I need to do? Oh, what do we know about where front and rear are in the current list of elements? In the general case, we don't know anything about where they are relative to the array, other than they're next to each other, right? Because I've filled the thing up, right? If I'm doubling the size of the array, where do I want all the elements to be? Well, I can't just copy them over to the positions they were in, right? So whatever was in the 0 index of the first elements array to the 0 index of the new elements array, because it's not going to wrap the same way around the tail because the tail is twice as far away now, right? So in essence, what I want to do is copy the front of the queue to element 0 in my new array. Copy everything over one at a time from the front of the queue to the tail of the queue to element 0 to element, well, whatever the new size is divided by 2, basically, right? And then I need to fix up the front and rear pointers before I'm done. Fix front and rear pointers. And then I can make this last line here, and we're ready to go. Right? All right, we'll come back around and finish that on Wednesday. I didn't put up the survey for the cards. Failure. Sorry. No cards today. You are free to go. See you guys on Wednesday.